Okay, suppose I gave you a problem that was read like this, like number 32 from your textbook. 14 minus x equals -7. We would solve that. Remember, the point of any equation is to get the variable by itself, right? We're trying to get the variable indicated by itself. In this case, the variable indicated would be x, right? Because there are no other variables around there. So what I'm going to do is I can either add x to both sides or I can subtract 14 from both sides. Either way, I'm going to get the same answer. I'm going to subtract 14, and I'm going to get -x equals -21. Problem is that x isn't by itself yet. There's still that negative hanging out on the outside. So I'm going to multiply both sides by -1, and I get x equals 21. Questions on that? Raise your hands if that looks strangely familiar. Like you've seen that before in algebra, geometry. Good, good, good. All right, number 34. All they can do is to add more stuff on before getting to the point where you recognize it. So let's take a look at this problem here. T plus 2t plus 3t plus 4t plus 5t equals 45. This does not yet look like this problem, but we can do something with 34 to make it look that way. Who can raise their hand and tell us what can be done with number 34 to make it resemble 32? Joy! Combine like terms. It's actually not even optional. You must combine like terms. 1 plus 2 plus 3 plus 4 plus 5. Does anyone know what that number is? Dom. 15. 15 t's, and that's going to get me 45. From here, we just do the opposite of multiplication. That is, divide both sides by 15. T equals 3. How are we all doing? Doing good? Chief, how you doing over there? Okay, 36. More layers. 3 over 4 minus 3 over 5x equals 2 over 5x plus 2 over 4. Raise your hands if you do not appreciate fractions. Okay, you will in this class. You will, because fractions are super easy. Okay. A couple of little caveats about this problem. 1, there's a bunch of fractions everywhere. 2, x is on both sides of the equal sign. Everyone see that? So what I'm going to do is I'm going to move all my x's to one side of the equal sign. I'm going to add 3 over 5x to both sides. The good thing about this problem is that what's 2 over 5 plus 3 over 5? 5 over 5, which is actually 1. X equals. So at the same time, we're smart enough, we can do this. I can subtract 2 over 4 from both sides. And we've already got common denominators here. What is 3 over 4 minus 2 over 4? 1/4. Chris, do you know that? Yep. How many quarters does it take to play Street Fighter at Chuck E. Cheese? 3. How many cents is that? How much cents is that? 75. Okay, Chris fixes the machines. He doesn't put money in them. Okay. D on both sides. Taylor, what do I do first? Yeah, subtract 2d. Remember, whenever you have variables on both sides, your first objective is to get all of the variables on one side of the equal sign. That's what you got to do. So that means subtracting 2d. You could have subtracted 8d from both sides. You would have gotten a negative number on the left. It's no big deal. You get 6d plus 2 equals 5. Now that should look like something you know how to work with. I'm going to subtract 2 from both sides here. So you get 3 equals 6d. And we divide both sides by 6. And d equals 2, right? No! D equals what? 1/2. Please do not make that common error. Questions before we move on? Okay. $40. 3 times 4 minus 5k equals 2k minus 4. Again, variables on both sides, but this time on the left side, there's another layer of stuff we got to do before handling the moving. So we can't just add 5k to both sides. When you see a number hanging outside parentheses, and there's stuff inside the parentheses, what do you think you should probably do? So, what do you think? The distributive property, definitely. So I'm going to distribute this in. This is 12 minus 15k equals 2k minus 4. Now I can either subtract 2k from both sides or add 15. I personally like keeping the variable positive. It saves me a step in the end. So that's 17k minus 4 equals 12. I'm going to add 4 to both sides. 16 equals 17k. K equals 16 over 17. Raise your hands if you were able to beat me to that answer. You beat me to it. Good. Okay. Last thing on solving equations that might give you guys a little bit of trouble, but it will most definitely put hair on your chest, would be a problem like number 50. Okay, they're going to tell you to solve this equation, I equals P R T, and they're going to give you a semicolon, and they're going to say T. That means, pay attention guys, that means you are solving for T. So what I'm going to do is I'm actually going to get rid of this thing, and I'm going to go ahead and change colors. Whoops. Blue and gold. Colors of my old school. Alright. If I'm solving for T, then I need to figure out what is happening to T. What mathematical operation is happening to T? What is it stuck by? P and R are stuck to it, but using what mathematical operation? Cheyenne, what's multiplication? So what's the opposite of multiplication? Division. So I have to divide to get T by itself. What am I going to divide on both sides, Chief? PR. Divide both sides by PR. That's going to get out of there. I get I over PR equals, whoa, T. Any questions about that? You're just doing opposite of what you see, and that's all you're doing. Right? Opposite of what you see. Let's up the ante a little bit. 52. DE minus 4F equals 5G, and we are going to solve for the letter E. Alright, so what I'm going to do is I'm going to... Liam, what do you think? Don't know. Okay, that's okay. What I'm going to do, remember, Liam, all I need you to know is what variable are we going to solve for? E. So I'm going to add 4F. Raise your hands if you agree with that step, adding 4F to both sides. Yeah. So DE equals 5G plus 4F. Now, Liam, I'm going to jump back to you, okay? How do I get E by itself now? Divide by what? Divide by D. That's exactly what I'm going to do. And again, it's no different than when you're solving like 5x minus 14 equals 28, right? It's the same thing. You're just solving, it's just more letters. And one thing you have to be comfortable with is that you're not going to get what I call a clean answer, right? Your answer looks kind of sloppy, doesn't it? It looks kind of ugly, right, Basil? Looks kind of ugly. So just, you got to be used to it. 54. Last one. QR plus S equals T, and you are solving for Q. You are solving for Q. Miss Flynn, what do you think is the first operation here? We are going to subtract S. That is correct. Remember, your objective is to get Q by itself. So QR should equal T minus S. And then the last maneuver, Dom? divide by r, right? Not divide by q, because you're solving for q, you're going to divide by r, so q equals t minus s over r. Raise your hands if you have any questions about that. Gabby.
Yeah. Okay. So, like after the semicolon, it's like it shows what we're solving for, right?
Yes.
So cute, and then we don't need that like on the rest of our equation.
No.
Like
You're only addressing this thing.
Okay.
And actually, you know what? In your book, they're a little more explicit than me. They're going to say it's going to say solve for q.
Okay.
So it'll be like semicolon solve for q. So you're only looking at the left side of that semicolon. Okay. Nate, what's up?
For number 50, you divided P and R. Is it okay if you just divided, if you took the long way and divided R
And then divided by p again? No problem. As long as you end up with this. You should end up with this as your answer regardless. Right?
Yeah.
So let's do it your way real quick. Okay, Nate had a good question. Do you always divide by both p and r at the same time? That's kind of a shortcut. So if we do this problem one more time, I equals PRT. If you divide both sides by, say, R first, then you're going to get I over R equals PT, right? And if I divide by P, what I'm doing, remember, dividing by P is the same thing as multiplying by 1 over P, right? Just like dividing by 2 is the same thing as multiplying by 1/2. So 1 times I is going to give me I, and then P times R is going to give me PR. So that's going to be the same thing as what I got up here. Yeah? Okay. Any other questions before we finish it up? Soph, how you doing? Good? Liam? All right.